7 point, it says 7.4 on the paper, but it's 7.3 in your book. It's assessing normality. If we are not told, then how do we know whether the data is normal and it is appropriate to use the empirical rule or the Z formula? How do we know which one to use? So if you have enough data, make a histogram. And if you don't have enough data, then make a QQ graph, which is in the StatCrunch, which I've never used. The only thing that I've ever seen done with these is for you to be able to tell, are they normally distributed or not? And the way that you tell that is you look at the data and is this linear? Yes, for the most part it is linear. And if it's linear, then the data is normally distributed. This one isn't really linear, so since it's not linear, it is not normally distributed. And this one is fairly linear, so we would say that it is normally distributed. All right, and that's basically all it's asking you to do in this lesson is check and see if the data, if it falls outside of these curves, it's definitely not linear. If it's all inside the curve, then they say it's pretty much linear. And that's pretty much all 7.4 is, or 7.3. And then normal approximations to binomial problems is 7.4 in the book. And to recall, in order to use this method, you need to verify that it is a binomial experiment. And if we say n times p times q, that has to be greater than or equal to 10. This is the same formula, it's just saying q is 1 minus p. It's no different. So the continuity corrections adjust from discrete binomial problem to the continuous normal version. That's what we're going to do right here. It's asking, is a normal approximation appropriate if n equals 18 and p equals 6? Well, if we do n times p times q, which is 18 times 0.6 times 0.4, this comes from 1 minus 0.6. That equals 4.32, which is less than 10. So no, it is not normal. 10 times 0.5 times 0.5 is 2.5, which is less than 10, so no. 20 times 0.1 times 0.9, which is 1 minus 0.1, 1 minus p, which is 1.8, which is less than 10, so no. And then 70 times 0.3, 1 minus 0.3 is 0.7, and that's 14.7, which is greater than 10. So yes, for this one, a normal approximation is appropriate. For the others, they would be not, because n times p times q is less than 10. So question 2. Here's the binomial question, and here's the adjusted point part. Well, the way that you adjust it is you add and subtract 0.5 from x. So if it's just the probability of A, then we're going to take and subtract 0.5 and add 0.5 to it. So this would be 1.5 So x would be between 1.5 and then add, which would be 2.5. It's like this one. We're going to, if x is less than a number, then it's going to be adding 0.5 to it. So probability of x, nope, wrong one. If it's greater than a number, we subtract. So x is greater than or equal to 1.5. P is of x less than 2. This is where, since it's less than, we add. So P is x less than 2.5. It's like this one. So x is going to be, these aren't supposed to be here. X will be greater than subtract and add. So P less than, so that's going to be x less than, and we add. X greater than, we subtract. It's like this one, so we subtract here and add on this side. And then number 3, Billy Ball claims to be a 76% free throw shooter. If Billy were to take 100 shots and find the probability of the following events, which would be A and the B events. So the mean, or the expected value, is N times P, which would be 100 times 0.76, which is 76. Standard deviation is the square root of N times P times Q. So the square root of N times P times Q is about 4.3%. All right. See if a normal approximation is appropriate. So we have to say N times P times Q greater than 10, which it is 18.2. So yes, it can be normally distributed. So x less than 72, we're going to do x less than, we add, so 72.5. And that's our continuity correction. And then we're going to find the z-score of 72.5, which is the data minus the mean divided by the standard deviation, which gives us negative 8 or 0.81. So our z-score is less than negative 0.81. Our mean is 76, and our standard deviation is 4.3. So we're going to look up negative 0.81, and we're saying less than, because that's what our symbol says, and we find that to be 0.2090, so we look up 0.81. So the probability that he makes less than or equal to 72 shots is 21%. Calculator notation would be normal CDF 0 to 72.5, the mean and the standard deviation.
Are you recording?
Yes. And then normal CDF -5, -0.81, 0, 1. This we will discuss together in class, the calculator notations. Alright, so this one, less than 78 or greater than 78, less than 85. So for continuity correction, this is going to become 77.5, and this one would be I believe that should be 85.5. So our z-score for 77.5 would be the data minus the mean divided by 4.3. Which this one is 0.35. And the z-score for the top one is 2.21. Okay, so the z-score is going to be between 0.35 and 2.21. We have a 76 mean and a 4.3 standard deviation. So let's see if n times p times q is greater than 10, which shouldn't change. So yes. So we're going to look up our z-scores, which would be 0.35, 0.6368, and then 2.21, 0.9864. So we know that we've got a 0.35 and a 2.21. So we're trying to find in the middle, so we have to subtract. So that's going to be 0.9864 minus 0.6368. Which is 0.3496 or 35%. And we'll talk about the calculator notation in class.